Okay, so hello everyone, good evening. Think we can start the session now. So I guess in the last session, we have discussed about the week 8 content, like the conceptual parts. So today I will summarize the week 8, and along with that, we can discuss the question from activity or from practice. Or if you have any doubt, you can ask. Just 1 minute. What happened? Just 1 minute. Okay, so is my screen is visible?
Yes. Yes, sir.
Okay. So basically, we are discussing continuity and derivative in this week, that is week 8. So in the last week, we have discussed few limits. So what is limit basically? And these are the few useful rules regarding the continuity of a function at a point. Okay. So just like go through it. The first rule is, say suppose yeah, so if limit x tends to a, f of x equals to f, then and limit x tends to g equals to g, then we can say limit f plus g equals to f plus g, right? So f plus g equals x, so f of g. So same thing applies for the subtraction part also. Okay, here you can see limit when x tends to a, f minus g of x, so we can say f minus g, right? And if there is a constant term, say that is c, which belong to real number. So if limit x tends to a, f of x gives us the f, and if we multiply with a constant term, we can directly take out that constant term limit. Say suppose I want to find out the limit of 3x sin x, right? So limit say x tends to 0. I can simply take that constant outside and I can apply the limit inside, right? So that is thing. And in the fourth case, like we have this, say limit x tends to a, f of x equals to f, and for g is g. Then limit x tends to fg equals to fg, right? So in the last time also discussed that we have two function like this, x into sin x. So what I can do, I can simply do the transfer the limit individually. Okay, that thing also I can do. And same thing for the derivative part. Okay, and most important thing is the sandwich principle. So that we have this we're discussing in the last session, in the last week 7 session. Okay, so we'll take few examples based on this. So what is sandwich principle here? If limit x tends to a, f of x equals to L, and if limit x tends to a, g of x is also equals to L, and is a function such that this condition is satisfied, then we can say limit f of x equals to L, right? So not limit f of x, it should be h of x equals to L, right? So if this limit is L, if this limit is also L, then we can say the limit of this particular function will also L, right? So this is basically a sandwich principle. So now let's try to find out, let's take one example based on sandwich principle. Say suppose I want to, okay, let us take this function only. Limit x tends to infinity, sin x upon x. Now I want to solve this limit by using sandwich principle. Yes, Ganesh? Hello,
Sir,
Ganesh?
actually, this is doubt session or
This is open session. If you have any doubt, you can ask. Uh, or I can continue with the part. We can discuss the question.
okay,
Do you
sir.
have any doubt in the this part, in the first
No,
part?
sir. But I have a doubt in activity questions, but I have no doubt in this part, sir.
Okay. Which activity?
Uh, 8.2 question number.
Okay. 8.2 will come to that. First, we'll discuss 8.1. Okay.
Okay, sir. Fine. Yeah.
Yeah, sure. So now we have to find out the limit by using this sandwich principle. Now, yes, anyone know how to find out the limit by using sandwich
Yes,
principle?
sir.
Anyone?
Like sin x will lie in between -1 and 1.
So sin x will lie between
Minus
minus
1
1
and 1.
and 1. Okay.
So if we divide everything by x
Hmm. If we
and
divide everything.
use the limit x tends to infinity, we know that -1 by x and 1 by x, if we put that limit, they tend to 0. So
We can
that
apply the limit and you can transfer the limit like this, right? 1 by x, limit x tends to infinity, sin x by x. Again, limit x tends to infinity, 1 by x. Okay. So we already know this limit is
tends to
0, right?
0.
1 upon infinity, 0. This also limit 1 upon infinity tends to 0. So by using the sandwich principle, I can say if f of x, my function h of x lies between f of x and g of x such that this condition is satisfied, then I can say the limit of the f of x is L and g of x is also L. So I can say the limit of this particular function also tends to L. So limit of this particular function will also tends to 0, right? So this is limit x tends to infinity, sin x by x equals to 0. Okay, so any doubt in this, but how we apply the sandwich principle? And please remember this, it is a standard limit. Limit x tends to 0, sin x by x equals to 0. Okay.
No doubt, sir.
Okay.
Sir, how to identify that where to use sandwich principle? How to identify
Still, we
situations?
can apply the sandwich principle when the function is bounded. So suppose we have sine and cos. Okay. So in that case, we can apply the sandwich principle.
Okay, sir.
But yeah, so when the okay, let me take one example. Suppose, for example, I have this function. Plus 7 sin x on x plus 3. I want to find out, okay, limit extends to infinity. I want to find out the limit using sandwich principle. How to do that? This is 3x.
You can do the same thing again. I mean, sin x
Yeah,
will lie in between -1 and 1, and we'll multiply it by 7.
yeah, that's correct. So same thing we can do. Like first, the sin x is bounded from -1 to 1. Just multiply it by 7 on both the side. What we will get? 7 sin x against 7. Okay. Now we want to make this particular expression right here. So what should I do here?
We will add 3x.
We can add 3x, right?
Can add 3x by x plus 3.
Yeah. So first we can add 3x, then -7, then 7 sin x. Sorry, here also 3x. 3x plus 7 sin x. 3x plus 7. Now we have to divide by x plus 3, right? So divide the whole term by x plus 3. Divide the whole term by x plus 3. And here also divide the whole term by x plus 3. Now apply the whole limit here. That is limit x tends to, say, infinity. Okay, here tell me what is the answer for this limit x tends to infinity for this particular f of x? I think in the last session, in the week 7 session, I have
3.
discussed this.
3.
3, right? How to solve that?
Taking x common from the numerator and denominator,
Yeah,
and
taking
then
x
feeding
common
that to
from.
the limit.
Okay. So we can take 3 common. So what we will get here?
Sir, x common, sir, not 3.
Yeah, sorry, x common. So we'll get 3 plus 7 sin x by x upon 1 plus 3 by x, right? And we have to apply the limit x tends to infinity. Now if I put x tends to infinity here, what I will get? 0, right? But what is this? We already seen, right? In the previous slide, x tends to infinity, sin x by x. What is the standard derivative?
0.
It is 0,
sir.
right? So if I transfer the limit, it will get 0. Here also 1 plus 3 upon infinity, that is 0. So answer will be 3. Now see whether by applying sandwich principle we are getting same answer or not. Now just try to apply the limit. 3x minus 7, x plus 3, 3x plus 7 sin x, x plus 3, 3x plus 7 upon x plus 3. Okay. So limit x tends to infinity, Here also limit x tends to infinity. Now what is this limit?
Sir, it would be 3.
Yeah. Again take the x common. So
Yeah.
7 by x will be 0, 3 by x will be 0. So again this limit will be 3. Okay. Same thing here we can do on this right hand side.
Yes,
Take
sir,
x
same.
common. Yeah. Here also the limit of this particular function will be 3. So by sandwich principle we can say the limit of this particular function f of x is also 3, right? So in this way you can apply. But we are going to learn L hospital rule. So in that case, you can easily apply that tool and to find out, okay, that thing already discussed. But this is the application of sandwich principle. Anyone,
If
any
we
doubt?
use,
Huh?
yeah,
Yes.
sir. If we use sandwich principle, then the function is necessarily bounded. It's a bounded function. Then I use sandwich
Yeah,
principle.
necessarily bounded. Yeah, it should be bounded function
Okay, sir.
between these
If
two
the function
functions.
is not bounded, then I can't use that one.
No, you cannot use. Yeah.
Okay, sir.
Then what is bounded and unbounded function?
So suppose, okay,
It oscillate
it's
between some
bounded in
range.
particular domain here. So suppose this is my x-axis, this is my y-axis, and this is the graph of, say, suppose sin x. Okay, so my this particular function is bounded from 1 to -1. Okay, so it will not go beyond 1, and also it will not go to -1, right? So my this sin x function is bounded between -1 to 1, right? Same for cos x also, it is bounded -1 to 1, right? So our range is upper limit and lower limit is fixed. That is the bounded function. Hello, you got it, right?
Yes, sir.
Yeah, and it should be in that particular domain. So that is the case. So this is about the properties of the
Sir,
limit.
if one side is bounded, still we can't use the sandwich, right?
No, because in other case here you will get, say, suppose instead of 3 you may get 1 by 3. Okay, so that sandwich principle we cannot apply here. Yeah,
Okay.
if it is not bounded on both the side. Yeah, that is the case. This is a limit. Any doubt in that part? Sandwich principle.
No,
Okay.
sir.
So now what is continuity of a function? The function f is said to be continuous if it is continuous at all the points in its domain. That is for all the point A for which f of A is defined, and limit x tends to f of A equals to, sorry, f of x equals to f of A. This condition must satisfied. So what is in order to check the continuity of a function, so suppose I have f of x. So first thing is that limit should exist, right?
Yes, sir.
Limit should exist. It means my
So
left
left hand limit and right hand limit should be equal.
should be equal. Second thing is that like this, like limit x tends to a, f of x must be equals to f of a.
The value of the function at a point which is equal to the
Yeah.
limit of the function.
We can say the f of a is defined. So then we can say this function is f of x. If both the conditions should satisfied, okay. If both the condition is satisfied, then we can say the function is f of x. It may be possible that limit exists. Okay, so both left hand limit and right hand limit exists, but this condition is not true. So in that case, we can say that function is not continuous. So both the conditions should satisfy. Okay. So for example, I take this function x square minus 9 upon x minus 3, limit x tends to 3. Now tell me, is this continuous function or not?
It is not continuous.
It's not continuous because the value of the function is.
This function is not defined when x equals to
X
3.
equal to 3, sir.
But the limit is exist.
Limit does
But limit
exist.
x, yeah, I can write it as x minus 3 and x plus 3, right?
Yeah.
Again,
Yes.
x minus 3. So I can
Six.
cancel it out.
Cancels and we get
Yeah.
6.
We get 6.
6.
Here you can see our first condition is satisfied. Limit exists, but it is not equal to f of a. If we try to put f of a here, we'll get 0 by 0 form, right? That is indeterminate form. So
Yes, sir.
this function is not defined at this particular point when x equals to 3, but limit exists. So we can say the function is not continuous at x equals to 3.
Sir, but we can able to extend this if the function is defined for the whole interval, but I explicitly tell like piecewise defined function, if I tell x is equal to 3, then it will be 6. So on that case, it will be a continuous function.
Sorry, if we define when this function is not defined at x equals to 3, you are saying that.
No, sir. Actually, I defined the
Hmm.
function is x square minus 9 divided by x minus 3 for
Hmm.
the whole minus infinity minus infinity to
infinity.
3 union 3
Hmm.
to infinity. When x is
Hmm.
exactly 3, the value of the function is 6. I explicitly give like the piecewise defined function. So for that one,
Okay.
the value of the function is 6 and the limit of the function
Mhm.
is 6. So it will be a continuous function.
Yeah. So then you can say, so suppose like we are saying like this, like f of x, say it is 6 when x is not equals to 3. Sorry, when x equals to 3, right? And
Yes,
just say
sir.
another function, say g of x when it is x is not equals to 3. Right? So when x is greater than equal to
Yes.
3, like this, like yeah, in that case you can do that. But say we could directly put the 3, but we are not getting the answer. So we are not getting
Yes,
this
sir.
particular
Yes,
value,
sir.
right?
Yes,
Yeah.
sir.
So it depends on the function, yeah. We can discuss, we'll discuss few examples. It is there in the activity. Yeah.
Okay, sir. Sir, I have a
Okay, any
doubt in
doubt?
y equal
Yes.
to absolute value of x. That's they are telling continuous.
When
Could
x
you
equals to 3?
explain with that example?
Sorry, I didn't get your one. Like what you said.
Sir, y equal to absolute value of x. Could you
Hmm.
explain with the continuity definitions what we have discussed now?
Y equals to mod of x.
Yes, sir. Exactly.
Okay.
At
So
the point 0, x tends to 0.
yeah. So basically this will be minus x when x is less than 0, and it will be equals to positive x when x is greater than 0, right?
Yes, sir.
This f of x equals to
Sir, x is greater than or equal to 0. We can able to put that one.
yeah, we can do that. This is the graph of this particular function, right?
Yes, sir. Yes, sir.
But this function is continuous. It is not differentiable. We'll come to that mod of x. But how to check whether this function is continuous or not? For that, limit should exist, right? Hello.
Yes,
Yes, sir.
sir.
Yes, sir.
Actually,
Yes,
that
sir.
point I little bit confused, sir, because the left hand limit is positive x and
Yeah.
the right hand limit is negative. So they are converged to 0, but
If you see left hand limit, that is 0 negative, that is my mod of x, that is minus x, right?
yes, sir.
Which is equals to 0. Now, if I go from the right hand side, that is from 0 positive, that is plus x, still it is equals to 0,
Okay,
right?
okay, okay,
So
okay.
my
Okay,
left
sir.
hand
Okay.
limit
Yeah.
equals to right hand limit exists.
Yes, sir.
I
Yes,
will
sir. Got
come
it.
to that this particular example when we will discuss differentiability, because this point is it is not differentiable, right?
Yes, sir. This is not
Yeah,
differentiable.
it is continuous but not differentiable. I will come to that one.
Okay, sir.
Okay. So here we can say if a function is continuous, then limit must exist, right?
Yes, sir.
Function is continuous, we can say limit exists and this condition is satisfied. So these two are the mandatory condition. So in order to our function should be continuous. So now let us take few examples from activity only. So this is the example. Now we have to find out the value of a and b such that the limit is the function is continuous. Okay, now tell me how to do that. First condition is limit should exist. That is left hand limit must be equals to right hand limit.
One.
Okay, now let us find out the left hand limit first. Limit x tends to 1 bx square, right? What is the answer here? You can simply put the 1, that is b. Now what is my right hand limit here? Limit x tends to 1 ax, right?
AX.
That is my a. But in order to this function to be continuous, my first condition is satisfied, right? It is LH left hand limit should be equals to my right hand limit. So I can say a must be equals to b, right?
Yes, sir.
Yeah, this is the first condition. Yeah. So
But one thing,
okay.
sir, why we are taking x tends to 1, sir, here?
Here you can see our function is continuous before when x is less than 1, and here also when x is greater than 1, this function is continuous. But we have to check
Sir, for
when x is equals
LHL,
to
No,
1.
no, my question is, we have taken for LHL limit extends to 1 you have written. So why should I take 1? Can I write 0 or infinity?
No,
Why?
no.
What is the
1 minus.
purpose?
0 is
One
already
minus.
1 minus, sir.
Okay.
Because we are
Here.
approaching it from
Okay, you're
that
talking
side.
about like this function. Okay. Naren, you're talking about this thing.
Yes.
Okay. Yeah, here we should write 1 plus. Yeah, sorry.
No,
1 minus.
I'm not telling that, sir. I'm asking you, we have taken limit tends to 1, isn't it, sir? So how we chose 1? Why we did not choose 0?
Because, yeah, this is f of x is continuous when x is less than 1. This f of x is continuous when x is greater than 1. So we have to check for this particular point whether our function is continuous or not when x is equals to 1. Because at this particular point we have two functions, right?
Okay, in some other question, if that was like x less than 2 and more than or equal to 2 means, then we'll check at 2.
Yeah, we'll check at 2.
Correct, no, sir? What I
Definition
told?
of
Yes.
the definition of the function is changing at 1.
Yeah, here you can see the function is changing at x equals to 1.
Okay. For in generality, we can say wherever it is changing, that limit we can check there.
Yes, you can say that. Yeah.
Okay. No issues, sir.
I
Thank you.
can't able to get it that y a is equals to b.
Okay, so our left hand limit is b and right hand limit is a, right? But here we have to see whether our function is continuous or not. For that, there are two conditions. Limit should exist, that is left hand limit should be equals to right hand limit, right?
Yes, sir.
So my a should be equals to b in order this function should continuous.
Yes, sir. Yes, sir.
Yeah, and the second thing is that limit x tends to a, f of x must be equals to f of a.
Yes,
Right,
sir.
this is the second condition. But here if you see the
Sir,
option,
it is
f is
okay,
always
but a and b are different values, na? I think.
Yeah. No, a and b are the same values. A equals to b. When a is equals to b, then only we can say that our function is continuous. Otherwise, it is not continuous.
Okay, sir. Got it.
Yeah. So f is always continuous. This is not correct because this condition should satisfy. F is continuous if and only if a equals to b equals to 0. No. If a equals to b, this is sufficient condition. So it is not necessary because if and only if is there, right? So this is also not correct. F is continuous if a equals to b equals 0. Yes, this is correct. F is continuous if a equals to b. Yes, this one is also correct. If you put, say, suppose a equals to b equals to 0, what you will get? 0, 0, right? So we are getting the same value at when x tends to 1. Our function is continuous. Now, if suppose if a equals to b, you change it to 5, right? Now, what you will get here? 5x and here 5x square, right?
5x square.
Yeah, but if you find out the limits, you will get 5, 5. That is our function will be
One thing,
continuous.
sir, once a and b are 0, then there is no function at all, sir.
Yeah, but for this particular value, if you go through option, this function will be continuous. Now, when we are getting this value 0 at this particular point, it is not like that at f equals to 0, the value of this function, particular function is 0. It is not that it's no function. It can be like this also, like this function is coming and is passing through this particular point like this. We are finding out the value when
Sir, f of
x
will
tends
be...
to 0.
Okay.
Yeah.
No, sir, what I wanted to ask is, if a and b are equal to 0, then the function will be constant, right? It doesn't depend on x. It will always be 0. If you take a negative number or more than 1, whatever it is, the value of the function will always give 0, right? No, the C option I'm talking about.
For this particular function.
Yeah, when I'm telling
Okay,
it's right, but the graph will be a straight line, right? Like constant function.
Sir, constant function is also a continuous function, right?
That does also work, right?
Right. Yeah.
That's what I'm saying. Yeah.
So when a equals, okay, this is 0, this is 0. It's constant function.
Yeah. It will be a constant function, that I'm telling.
Yeah, this line only. Yeah, this
Yeah.
is also correct. Yeah. But this is not a such necessary condition, right? For any value when a equals to b, we can say this function is continuous.
Yeah.
Okay. Now the same thing is here. Only we have to find out the value of
Sir,
a
one more
question. Sir, please fresh question.
Sir, still that third condition, I'm not able to get it, sir.
Which third condition?
Why if x equal to 0, sir?
Sorry.
So
Here,
why
okay.
if x equal to 0?
Here. Why
Yes,
fx
sir.
equals to 0?
Yeah,
No.
yeah.
We are talking about the condition when a equals to b equals to 0. If we put the value of a and b here, then it will become 0, right? It will be a line, right? Continuous function.
Oh, sir, got it,
For
sir.
this case, we are
Okay, sir.
talking about. Yeah. Yes, Nathan, you were saying something?
The fifth question, please.
Sir?
Yes, Naren, go ahead. Yeah.
Yeah. See, still I'm able to observe that when a equal to b equal to 0, our function f of x, the x is having some unit numbers. There where a is 0, then ax will become 0.
Yes, 0. Ax will
The
become 0.
bx
Yeah.
square also will become
Become
0.
0. Yeah.
So in the graph, where will be that point, sir?
It is a straight line
The
only. It is
x-axis.
x-axis only. It is
X-axis,
x-axis only, like this line. X-axis
Okay.
only. It is continuous,
So y
right?
will be f of x will be 0 for that. Y will be 0.
Yeah, because it is x-axis. Now, if you put any number for x, say if I write like 0 into x, right? Now, if you keep any number of x, still your value will be 0 only, right?
Correct, sir.
Right.
Now, when x is okay more than 1 or less than 1, still it is 0 only.
Because 0 multiplied by
both
x. If you
sides.
increase x even, because we still get the 0 answer only, right? That is my
Correct.
x-axis
Yes.
line. Yeah. Okay.
Okay.
Yes, someone is saying third condition is not understand.
Thank you.
Okay. Yeah. Yes. Anyone? Any doubt?
I only asked it.
Okay. Fine.
Sir, in fifth
Anyone? Any
question.
doubt? In first
Sir, in
question.
fifth.
Okay. In this activity, first, fifth question, right?
Yes, sir, in fifth
Okay.
question.
Let me discuss first this question, then we can discuss that. This is also doing same activity. Okay. Now try to find out the value of a and b. What is a and what is b here? Same condition you have to think. Like my function is continuous means limit should exist and that limit should be equals to f of a. That two conditions should satisfy. Just find out the value of a and b. But for that, you should know the property of limit in order to find out the limit of this particular function.
Sir, it's 1.
Sir, it's 1.
Okay. Yeah.
Half plus
So
half.
limit should exist. So my left hand limit should be equals to left hand limit. So what is my left hand limit? Limit x tends to 0 negative. Now which function I have to take? This one, or which one?
Sir, the
first
sine one.
X greater
Sine
than 0.
ax by x. That one.
So sine ax upon x. So how to evaluate this limit? Yes, anyone?
Multiply and divide by a.
Multiply and divide by a.
Multiply, divide by a.
Yeah. We have a standard limit when limit x tends to 0. Sine of
Sine
x
x by
upon
x
x.
is 1.
This coefficient must be same, right? Here.
Yes, sir.
Yeah. Then only we can apply. So here
X1
we can
equal to
multiply
b.
and divide by a. So my this whole limit is equals to 1, right? So that is my a. Now what is my right hand limit here? Limit x tends to 0 plus. Now I have to consider this particular function. Yeah. So x upon tan inverse of 2x. Now how to evaluate this limit?
We can use L'Hopital rule, I think.
Tan x divided by 2x.
We can also do that.
So we can break it to sine and cos and then bring x down, then again
No. It
plus
is tan
minus.
inverse. Now how we can break
Sir,
it
we
into
can
tan
substitute tan.
Oh, tan inverse, sir. Then 2x
Yeah.
equals to y. Then tan y. Then we can do it, right?
Yeah.
Tan inverse function, we don't know, sir.
I didn't see that
Sorry?
tan inverse. Sorry, sir.
Okay.
Sir,
So there is one standard limit tan inverse of x upon x, limit x tends to 0, that is also equals to 1.
1 year.
Okay,
Yeah.
standard.
But even if you don't know, you can derive it. Like say suppose here tan inverse of 2x, you can put the substitution as say t, right? Now 2x equals to tan of t, right? Tan inverse will go on this side.
And x
Now my
equals to
x
half of
equals to
tan
tan t of by 2.
by 2.
Now just put all this thing in the here, like inside the limit. But when my x tends to 0, now here when x tends to 0, what is the value of my t? What is the value of my t?
Undefined.
0.
Tan inverse 0 is 0.
Tan
Right?
inverse
Also
0
tend to 0.
Yeah, so t also tends to 0. So my limit will change to limit t tends to 0. Instead of x, I can write tan of t upon 2. And instead of this tan inverse of 2x, I can write simply t. Right? Now here also we have one more standard function, limit x tends to 0, tan of x upon x, this equals to 1. Right?
Yes, sir.
So this is also correct. So if I apply this limit here, the 1 by 2 take common. So I can say limit x tends to 0, tan of t upon t. So it is 1, right? So here answer will be 1 by 2.
By 2.
Here also if you apply this formula, yes.
Sir, please tell me that
2x
how we
equal
are
to
able
tan
to
t.
change the limit.
Just 1 minute. Harshit, yes, go ahead.
Sir, please tell me once again, because I face problem over here, that how you can able to change the limit of t to 0.
Okay. How I change this limit of t to 0, right?
Yes, sir. Yes, sir.
So when my x tends to 0, what should my value t tends to? You can simply put x equals to 0 here. So tan inverse of 0 is basically 0, right?
So your pointer is not visible, sir, where you are
Yeah.
indicating.
So tan inverse function, sine, cos, tan, all those things we explained, sir. But tan inverse means what, sir?
This is an inverse trigonometric function. These are the inverse trigonometric function.
Okay. So
we are not aware of it.
So even if you don't know that, we'll mention in the question, like you can use this property, tan inverse of x, limit x tends to 0 equals to 1.
Okay. Can you also explain the line how 2x equal to tan t is how you derived that?
I have just assume, or you can put tan of inverse 2x equals to t, right? Now
Correct.
2x, the tan inverse t will go on this side, it will become tan t. It is
just
inverse
like
function, right?
multiplication and the division, that inverse will become, once it crosses the equal to sign, it becomes tan. It's a
No,
standard form.
this is not correct. Tan inverse of t is not equals to 1 upon tan t. This is not correct.
Correct.
This is not correct.
For inverse function
That's
also.
why I was not clear understanding how it would be tan t.
Yeah. Tan inverse of t is not equals to 1 by tan t, right? It is an inverse function. It is a different inverse trigonometric function. Here you can, I have just assumed that tan inverse of 2x equals to t. Then tan inverse will go on this side and it will become tan t. This tan t then equals to 2x. Right? So now x equals to, just divide here tan t by 2.
F inverse x is the inverse of fx, so tan inverse is inverse of tan x.
Tan inverse is the inverse of tan x. Yeah, that's same thing. I just
So when x
substituted.
is 0, when tan t by 2 also will become 0, sir.
When my limit x tends to 0, I have to see what will my t will be, right? Because I am changing the limit from x to t here, right? Variable. Here I have the limit x tends to 0 and my function is a variable of f of x, right? But here my function will be f of t here, right? So I should know my limit for this particular t variable. So when my x tends to 0, my t will tends to 0 also. If I say tan inverse of 2x equals to t.
Sir, can we divide numerator and denominator by 2x?
Yes, I am coming to that. If we know that like limit x tends to 0, tan inverse of x equals to 1, you can simply use this like this, right? Divide and multiply by 2x.
Right.
And this expression will now become 1.
Yes.
And here you can select 1 by 2. Yeah.
Exactly.
That thing also you can do. Yeah.
This is the fastest technique.
Yeah, but you should know the this term, right? This property.
Yes, sir.
Yeah. So here, according to our condition, what we are getting,
A equal to B
A,
equal to half.
yeah. So here I am getting our left hand limit should be equal to right hand limit. So my left hand limit is A and my left hand limit is 1 by 2.
By 2.
So I am getting A equals to 1 by 2. This is my first condition I applied. But my second condition is limit x tends to A, f of x must be equals to f of A, right? In order for the function to be continuous. Now apply this second condition here. Now limit x tends to 0, f of x. Here you can see it is given B, right? When my x tends to 0, f of 0 will be B, right? So f of 0, if x equals to 0 means f of 0 is given to us, that is B here. So this value is B, right? Now I already have this limit, that is my A or 1 by 2 you can say. So here also A equals to B and already A is equals to 1 by 2. So I can say A equals to B equals to 1 by 2. So my A plus B equals to 1, right?
Yes, sir.
Hello? Yes. Anyone, any doubt in this part?
No, sir.
No,
No,
sir.
sir.
Yeah.
Sir, in our lectures, inverse trigonometric functions is not covered. So we need to study that one too.
No need to cover inverse trigonometric function, but your standard limits you should know, like limit x tends to 0, tan inverse of x upon x is equals to 1, right?
Okay,
So
sir.
standard limit, standard derivative you should know.
Okay, sir. Sir, and that one limit extends to 0, sin x by x equal to 1. So which is equivalent to say limit extends to 0, x by sin x is also equal to 1. That's right, sir?
Yes, yes. Limit x tends to 0, x by sin x is also equals to 1.
Okay, sir.
Right?
Okay, fine.
So basically it's like this only, na? Limit x tends to 0, 1 upon sin x upon x. You can transfer this limit in the denominator, it is equals to 1 only, right?
Yes, sir.
Okay.
Yeah. Here also I have done the same thing. Tan inverse of x equals to x is 1, but just if I divide by x on both the sides, x will come on this side, right? I can again multiply and divide it by 2, like this. So it is
Okay.
equals to 1.
Okay,
Yeah,
okay.
then equal to 1 by 2, right?
Yes, sir. I also
Yes,
had the
sir.
same doubt. Okay, got it, sir.
Okay.
Thank you.
Okay, so this is about the lecture 8.1 based on the continuity. Any
Question
doubt
5.
in limit and continuity part? Okay, question number 5. Just let me share my screen. Same activity, na?
Yes, sir.
Okay. Hello, is my screen visible? Okay, I'm not sharing it.
No, sir. Yeah, now it's visible, sir.
Yeah, this question, right? Okay, which of the following options is true? There exists a continuous function f from this to this such that f of 3 equals to pi. So there can be any function which exists from this particular domain to this range. So such that f of 3 is equals to pi by 3. So exists any continuous function, you can say that. Say suppose if I say pi by x, right? 3 pi by x. So if I put f of 3, I will get 3 pi by 3. This is one of the thing you can see because yeah. And if I put any value, I will get the value between these two, right? So yeah, this is you can say one of the function. We are talking about there exists a continuous function. It can be any function. It can be either one function or multiple functions can be there. But there exists one function such that our this domain is 1 to 5 and range is 1 to 7 such that f of 3 equals to pi. Okay. So simply you can consider from this, I can say I can just derive this thing, right? It means if I put x equals to, I will get pi. Now if you put just try to put any value between 1 and 5, just try to put 3, right? Already put 3, right? So just try to put 4. So 0.75 into pi. So basically it will lie in this range only, right? This is the case. Now there exists, hello, who asked this question?
Yes, sir. I got it, sir.
Yeah. Okay. Now same thing. There exists continuous function. You can think about the function which satisfies this particular condition. There exists a constant continuous function f r2 which is bounded. Yes, you can see our sin x is bounded, right? Now there exists unbounded continuous function. It can be any function which is unbounded continuous. This is also correct. Like all the options will be correct here.
Okay, sir. So we have to put it equal to x. Find any function which can
Yeah, just
prove
this
this.
you have
Prove
to
that.
take this particular sentence and think whether it is correct or not. So like this one function, then it is correct, right? Any function.
Okay.
Yeah.
Okay, sir. Thank you, sir.
So where I was. Okay, this is about the continuous of the function. Now we'll move to the differentiability. Now, according to our definition, let f be a function defined of an open interval around a, then f is differentiable at a if this particular limit exists. Okay, if this limit exists and we are getting the value of so suppose L, then we can say that this particular limit is my f of x. So I can say if this limit exists, then I can say my function is continuous. Sorry, no, function is differentiable at this particular point a. Okay, so for example, let us take the example of, okay, what is the derivative of x square?
2x.
2x, right? Now, yeah, okay. Now let us just find out the derivative of x square using this particular limit. So what will be the value? Let limit h
The first
tends to
property,
0.
sir?
X plus
Yeah,
h the whole.
here you can see this is the definition of differentiability, right?
Okay. The first property, got it.
So I have to replace this x by x plus h, right? So it will be my
Yes.
x plus h square minus f of x. And this is my f of x, that is x square divided by h, right? Now I will just expand this x square plus
2xh
2xh
plus h
plus
square.
h square minus x square divided by h, right? Now this x square will get cancelled. What I am getting? 2xh plus h upon h. Now here also a limit is
So
there.
h squared, sir.
Limit.
H square.
Okay, here, sorry, h square. Now I can take h common, right?
Yes, sir.
H upon
2x
h.
plus h when apply the limit.
H will get cancelled. Now what are remaining? Limit h tends to 0, 2x plus h. What is the value here? Just put the limit.
The 2x.
Right? So this is the derivative of this x square. Yeah. So you can find out derivative of any function by using this thing. Okay. Just apply this particular formula, and if this limit exists, that particular value will be the derivative of this particular function f of x. Okay. Now do we have any blank page? Let me see. So now let us discuss about that function f of x equals to mod of x, right? Now this function is negative when x is less than 0. My function is positive when x is greater than 0, right? Now we already discussed this, my function is continuous, right? Like this. This is my y, this is my x, and this is my graph. Okay. This my function is already continuous. Now, can I check whether this function is differentiable or not? What
Yes,
is
sir.
that
Using the first.
definition?
Yes, sir.
Yeah.
Yes, sir. Using definition.
Definition we can show, right? Now,
Mod of x
here
plus
a limit h0 means we have to check for both left hand and right hand limit here. Now, if I check for left hand limit, that is my limit h tends to 0 negative. I have to take this particular function, right? Minus x. So I can replace this minus x with x plus h, right? So what I will get? Minus
Minus
x.
x.
Minus x, yeah, minus x minus h
Plus
plus
h.
x.
Right?
Yeah.
Minus of
minus x
x divided by h.
divided by
Right?
h. Yeah.
So what I will get? So this minus this will get cancelled. That is minus 1, right?
Minus 1, yeah.
Now let us check for left, right hand limit. Limit h tends to 0 plus. Now instead of minus x, I will get simply x plus h, right?
X plus h. Yes.
Yeah, minus f of x is my x only. Now here h.
Yes.
So x plus h minus x upon h. So minus x will get cancelled. I am getting here 1. So my left hand limit is not equals to right hand limit here. Means this limit is not exist, right? This particular limit does not exist. So I can say it is not differentiable when x equals to 1. Sorry, when x equals to 0. Now this particular function is not differentiable when x equals to 0, right? This is the way to check that. Just keep this in mind. If you feel like in any question, if you want to check for the differentiability, just put this limit and try to find out if it exists. Then the limit, then it is differentiable. Otherwise, it is not differentiable. Okay, here you can say I'm getting -1 for left hand limit and my right hand limit is 1. So it is not equal. So limit does not exist. It means my function is not differentiable. Okay. Anyone, any doubt in this part?
No, sir.
No, sir.
So this is differentiability. This is one question, activity question. Now try to
Sir,
solve.
I have a doubt in you're telling that the function is differentiable. So what is the difference between the derivative and differentiable?
Differentiable means derivative exists. The function is differentiable means derivative exists.
For every point or a particular point, sir?
No, at that particular point, is function is differentiable or not, we can find out.
So we simply say the function is.
If we need to find out the differential at any particular point, then we can apply that limit. So for every continuous function, say for sin x is a continuous function, we can directly say the standard limit is cos x, right?
Yes, sir.
Yeah. Okay, now try to find out x minus 2l plus m. Means basically just find out the value of x, l, and m. The function is continuous, so we have to apply that 2 point, and it is differentiable also, right? So it should be equal at when x equals to 1. So here I can say my left hand limit must be equals to right hand limit. My second condition is f of a must be equals to limit x tends to a f of a. Okay, and for differentiability, and this both the function and differentiable, it is must be equals, right? It is left and this is right. Now just try to apply these three condition and tell me.
If it is differentiable, then what is the
It is
reason it's
continuous.
continuous?
No, we are just mentioning if it is continuous and differentiable at x. But even if I say it is differentiable only, then you can it is continuous directly, indirectly. Yeah. If a function is differentiable, it is continuous and its limit exists also. Just try to find out, like even approach you can tell. What is left hand limit? What is right hand limit?
Okay.
So left hand limit must be
2k
x square plus l, and here my right hand limit l square plus kx plus m, right? Now what is this limit? Left hand limit?
So 2k.
K plus L.
K plus L.
K plus l. And what is this
Yes.
right hand limit?
L plus
K plus L plus M.
Yeah. And now according to first condition, both should be equal, right? So L plus
Yes.
K equals to L plus K plus M. So this get cancelled, means M equals to 0, right? I can say M equals to 0 here, right?
Yes, sir.
Now think about this particular condition. Differentiate both the expression when x equals to 1 and equate it. What I will get? What is differentiable of this? F dash of kx square plus l.
2x, 2kx.
2kx, right? Yeah. And what is the
X
differentiable of this?
2lx plus
2lx
plus k.
Plus k.
Yeah. So here I will get 2 xl plus k, right?
Yes.
Now both should be equal to xl. Okay, so we are saying a differentiable at x equals to 1, right? Now
1.
at
So
x equals
2k,
to 1, it is 2k only,
2k.
Okay.
and here
2l plus k.
2L plus K.
2l plus k, right? That is
Yes.
at x equals to 1. Now equate it to k, right? 2k
K
equals to
equal to
2l plus k.
2l.
So k will go on this side. So 2k minus k equals to 2l. So that is
K is
k
equal to
equals to
2l.
2l, right? Now k equals to
yes.
2l and m equals to 0. Just put here. Instead of k, I will put 2l minus 2l plus 0. That is 0 basically, right? The answer of this particular value is 0.
Okay,
Yes,
sir.
anyone, any doubt? This is how you apply the the theorem of continuity, right? In order to find out the value.
Sir, for the chapter 8.2, I have a doubt in question number 7, sir. Third option.
Which activity question number 7?
Activity 8.2, question number 7.
Okay. Oh, my screen is visible, that portal? No.
No, sir.
Okay. This question, right?
Yes, sir. I have a doubt in third option.
Yeah. Let f of x equals to a rational function, then f is differentiable at x equals to 0, right?
Yes.
This is correct, right? X square is a rational function, differentiable at x equals to 0. This x square is continuous everywhere, right?
Yes, sir. X square is
It
continuous
is
everywhere.
differentiable everywhere, yeah. So we can say that it is differentiable at x equals to 0. It is continuous and differentiable everywhere, x square.
Yes, sir, but a little bit because I think the both limits like left hand limit and right hand limit maybe that doesn't exist because rational and irrational maybe the function is jumping.
Yeah, but when we are talking about x equals to 0, so in that case we can consider this, right? X square differentiability.
Oh, okay. We assume x is 0, so 0 is a rational number. So for that one, we choose x square. So x square is differentiable at every point. So that's why we choose. So that's
Yes,
the
it
point
is
you
correct
tried to
one,
prove.
right? Yes.
Okay,
Yes, it
sir.
is
Yeah,
correct
got
one.
it, sir.
Yeah. Okay. So this is about.
In that question, the extra information is only misleading us. That's all. You have to what do you call ignore it. That is f of 0 is f of x equal to 0 when x is irrational. That statement is not required in that question, no, sir. Actually, why they
No,
have given?
it is piecewise function, like it is equals to 0 for irrational number. But we're talking about at differentiability as equals to 0. So then we can say.
Correct, sir. But in even if that information is not there, also the answer will be same only. Whether it is that
Answer will
information
be
can be
same.
ignored.
Yeah.
So it is only giving extra information, whether the student knows or not, we are checking.
Yes. Yeah.
That information is not required, though, actually.
Yeah, but you can expect such question, na?
Okay, I understood, sir.
Yeah.
Thank you.
Sir, but I can clear that because differentiability implies continuity. So continuity that implies the limit. So
Limit,
for
yeah.
that one, at the point exactly at the point 0, so we have a small interval as a epsilon distance. So for
Such
that one we have a irrational numbers too.
Irrational number.
So at that point it is a jumping function. So
We are just
how
taking
I
as
can
x equals to 0, right? differentiability.
Sir, could you
Anything
grab
at
that
that point.
function?
X square is basically upward parabola only, right? That is from the vertex at 0 origin.
Yes, sir.
Yeah.
Okay, sir. Okay, yeah, got
We
it.
can think about it. Yeah. So okay, I think everyone knows the standard derivative. Or shall I explain that? What happened? Okay, so these are the few rules
Sir,
of
one more thing, one more. Now I am just confusing, sir. See, f of x equal to 0 when x is irrational, isn't it, sir? In that question. So when I put x equal to √2, then x square will become 2, no, sir? So how they are saying it is 0?
So if you put x equals to
√2,
√2, x
then
square will be 2.
it's an irrational number. So when
No,
x
we are
is
talking
irrational,
about the f
x
of
equal to
x.
0.
We are
F
considering
of
f
x
of
equal
x
to 0.
equals to 0 when x is irrational. Just like
F
that
of,
only, no?
yes, sir. But now, in parabola, our √2 is also there, no, sir? When x is √2, you have f of x is some other x square means it is 2. So
No, the function is not defined for
Because
that.
you didn't
Yeah.
take that function now.
Yeah. When x equals to, if I'm putting √2, that function is not valid, na x square.
Because x square is only valid for rational. So
Rational
√2
number.
is a irrational number. So irrational number, they explicitly tell it's 0. So
0.
At that point where x is equal to √2, what will be the, I mean, the graph will be, it will not be a
F of
parabola,
x
no, sir?
equals to 0. No.
It is not
That
a
function is
parabola
not
then.
defined when irrational number, no.
So it is, the graph will not be a parabola.
So that is a piecewise function, I'm saying, like
So what is
how to
piecewise
put
function
it,
means, sir?
like mod of x, we are saying that is piecewise, or just this particular function, like absolute
Piecewise
greatest
function
integer
means
function, like this
definition
here.
changes.
Yeah, at this
It is
particular
not
point.
differentiable, no, sir?
Anyway, sir, we are defining the function. So if we define the function that it is not available for irrational numbers, that should be adequate.
Yes,
Is
yes.
that correct?
In the question we mentioned it is not if x
Yeah.
irrational number, f of x equal to simply 0. That's it.
Yeah, so that is the way we are defining the function. So that
Yeah,
should
we are
end
defining.
the, yeah, exactly.
Yeah. Okay. Okay, so for that you should know the different derivative, I think. Okay. First I will go through it, then we'll get. Okay, so here there are few rules. So if f of x and g of x is differentiable at point A, then we can say that differentiable, like we can differentiate if plus and minus, we can simply differentiate transfer dt of x. So for example, we have 3x square plus x plus 2, and we have to find out the differentiable of this, derivative of this. So I can simply transfer this derivative to individual term, right? Like this. So this is plus minus, it can be anything. Now, if there is a constant function, okay, say constant term c, we can take that constant function outside. Say, for example, I'm talking about 3x square, the derivative of this will be 3 taken outside ddx of x square. Okay. Now, same for the subtraction. Okay. But okay, at first you should know the standard derivative. Okay. Now, first tell me what is the derivative of x to the power n? Does anyone
nx
know?
power
Nx to the
n.
power n minus 1.
minus 1.
1. Derivative of constant function, constant number.
0.
0, sir.
0. Derivative of log x.
1 by x.
1 by x.
1 by x.
Remember here it is log to the base e, right?
Natural log, sir.
Natural log. So suppose if I say log to the base a, then in that case, what will
1
be the
by
derivative?
By
x
x
ln
log
a.
8. Log base to the e a.
1 upon x log to the base a,
Log to the
right?
base e. Yeah.
A.
That is log e, right?
Yes.
Yes, sir.
So like you can simply, even if you don't know that, you can simply apply the change of base rule, that is log of x upon ln of a, right? And thus
So
ln of x.
I have one query. I mean, if you want, I can ask now, or I can wait till you finish this
If it
particular
is
thing.
related to this,
Yes,
we
it's completely related to this. Well, not specifically
okay.
to what you're writing, but given that we have covered limits and differentiation in 2 weeks, in week 7 and week 8, what exactly is the expectation from these 2 weeks? Should we know limits and differentiation to what level?
Whatever we have
The reason I'm asking is
covered,
like
yeah.
the reason I'm asking is because the things that you're explaining now, they seem to imply that we should already know limits and differentiation, and you're basically revising it.
Yeah.
Is
So
that the expect?
this thing you already learned 11th and 12th, right?
Yes.
Just simply
But I am
like
commerce science
summarizing
student. I have not learned actually, and that's also an issue with me. I am also spending a lot of time now.
Yeah.
And I don't have time that much.
But even if you just go to the content, we'll ask the question from the content only, because if you see some of the question, we'll mention the hint also, like limit x tends to 0, tan inverse of x equals to that is 1. So that we will mention in the hint only. But you should know the calculation how to do the standard derivative. That is
I
expected.
think what would really help us, or at least help me here, is if some well, I guess what the goals could be defined for these 2 weeks, that at the end of these 2 weeks, this is what you're expected to know. And this is the reason why we're teaching you this would be helpful. For me, I have already studied differentiation and everything, derivatives, integrals, everything for quite some time. But what I'm missing here is the context of these 2 weeks with respect to the rest of the course. The first 6 weeks the flow was very good, so I could understand why it's happening and correlate very quickly. The last 2 weeks have been a bit tough to absorb because I'm not clear what is being taught here. Is it entire limits and differentiation, or is it something specific in this area that we need to know, like continuity, tangents?
So no, we are just summarizing the content, and whatever we are discussing in the course, that is enough. Okay, if you see the limit content different, it is a huge topic, right? It will take 2-3 months to discuss
Exactly.
everything.
Sir,
Yeah.
but the videos are in mathematics 2 course, sir. So I have doubted why suddenly they are putting that max 2 videos.
No. Initially it was in Maths 2, but from the January this term we have included this part in Maths 1 only. So we have
It's
just
like
rearranged the content.
introduction to calculus, kind of.
Yeah, we have rearranged the content. That's why.
Okay, sir.
And also, if you see the portal, we have calculus book also. You can just go to that book. If you just go through the book and all the questions, that will be enough. If you don't know the this part, if you're not learned this part, but we should expect that you should know the standard derivative, standard limit of this particular thing. Then only you can apply this on the question, right?
Sir, we are not getting time to digest all these things and practice every week, bombarding with new contents and all that. That is
So
a
that thing
problem.
will
The
be there.
time is the main problem, sir, with us now.
So that thing is there. Even if you are a campus student, the same thing will happen.
Yes, sir.
Yeah.
But
Okay. So
Like for non-science background, this will be very hard. Whoever did not study maths
yes,
2
yes.
years.
I spent all day in 2 questions yesterday. It's around 11 hours. And then find out tan inverse x upon x is another formula that was not taught. And I was not knowing derivative. So I can tell.
Yeah, see this most of the topic are covered in 11th and 12th. And so, but we expected that you should know those basic derivative and limit, that standard derivative and limit. That's whatever we are going to cover. If we see the composite rule is there, composition is there, substitution is there, right? So that part is there, but there are other things, a different way that we can find out that we are not covering in this course. So whatever there is in the content, just stick to that. And but your calculation is the main thing here. Like you should know the standard derivative, standard limit, how to do the calculation. Yes, Jivraj.
Sir, we are learning limits and differentiability just to know about tangents, I think.
No, in future courses also in MLT and Maths 2 also you will be using the basically application of the derivative. But these are the basic mathematics like everyone should know if we are going for Like if you want to derive anything, limit is the must, right? You just take the interval, small thing, and then we just try to do that, right? Okay, let us discuss this first, then we can discuss. So x, n, c, ln. Now what are the standard derivative again? Derivative of sin x and cos x you all know, right? Sin x is cos x.
Yes, cos x.
Derivative of cos x is sin x.
Minus sin x.
Negative sin x.
Yes, minus sin x. Derivative of tan x.
Secant square x.
Sec square x.
Sec square x.
Secant square x.
Derivative of cot x.
Cosec square x.
Minus
Minus
cosec
cosec
square
square
x, I
x.
guess.
Cosec square x.
Square
Secant
x.
square x.
Yeah. Okay. Derivative of sec x and derivative of cosec x. Tell me.
Sec x
Tan
is sec
x,
x tan x.
Sec x tan x
Yes,
cosec
sir.
x.
Secant x tan x minus
Tan
cosec
x
Cosec x
is
is cot x
Tan
sec x.
cosec.
Sorry.
So
Derivative
cosec
of cosec.
cosec is minus cosec x cot x.
cot x.
Minus cosec x
Just
cosec.
one
So
by one.
minus cosec x
Minus
cot x.
cosecant x into cot x.
Cot x, yeah.
Minus cosec x into cot x. Right? Okay. So these are the standard derivative. Anything I'm remaining? Number is there. Okay. One more thing. Exponential. What is the derivative of a to the power x?
E to the power x.
A to the power x.
A to the
Log.
power x.
It's a to the power x.
A to the
log A, I
power
guess.
x.
Log A. Sorry, ln A.
Log a.
Yeah, ln.
Into ln of a, right? And derivative of e to the power x, that is e to the power x
E to
one.
the power
E to the power x.
E to the power x.
Itself.
So
Divided by df of
derivative
sin over
of 1 by x. What is derivative of 1 by
minus
x?
1 by x squared.
Minus 1 by x square.
Minus 1 by x square. So you can also think like this in this way. So it will go x to the power minus 1, right? You just apply
So
this
minus
thing.
1 coming to front.
Yeah. Minus 1 come into front and you can just subtract minus 1. So it will be
Subtract
minus 2.
so x square.
So again you can go on like that. Yeah.
Denominator.
So yes. So this is yes, and just the standard like we can use in many way, like derivative of root x.
1
Just
by
apply
2
this. Yes, 1 by 2 root x. You should know this because it will become a calculation much simpler. So these are the few standard derivative. Just go through it, or you can just Google it also. You can find it out. Or if you just refer to the NCERT 11-12 textbook, and in the last page it is mentioned all the derivative. Just go through it. Okay. So now we discuss the composition, that is the chain rule, right? Composition function is there, then L hospital. Okay, remaining. Okay, this one is remaining. What is the product rule first? Okay, suppose I have function f of x equals to x into sin x. Okay, now I want to find out the derivative of this particular function. Okay, now what is product rule here?
x into
Derivative of first function into the yes, same thing. So derivative of first function, take the other function as it is, plus derivative of another function, take the first function as it is. So if you apply the product rule here, just take the derivative of x, that is 1 only, right? So keep the other function as it is, that is sin x, plus derivative of other function, that is sin x, that is cos x, and keep the other function as it is. So basically it is sin x
plus x cos x.
X cos x. This is the derivative of this particular function. Try to find out derivative of this particular thing. This derivative of this particular function f of x.
The quotient rule is also applicable for this question now.
Quotient rule is also you can apply, yes. But yeah.
It's done.
Oh, how to apply product rule here first?
So we can take the first term as A and second term as B and just as well. I mean, the normal way.
Yeah. So just take the derivative of this, that is 5. Sorry, the derivative of 5 is 0 plus 3x.
That is 3, sir.
3 only and keep the other function as it is. Then plus keep the first function plus 5 plus 3x and derivative of this particular thing. This minus 3 will come down and minus 3 minus
X
1,
bar
right?
minus 4. Yeah.
That
Yes.
is. So this is how we apply the product rule. Okay, just note it down. Now about the
So we
quotient rule.
also do if we
Yes.
if we multiply the x power minus 3 into the two terms, so 5x power minus 3 plus 3x power
Directly
minus
you can
2.
transfer it. Yeah.
Yes, sir. Got it.
Directly you can do. Yeah. And I just want to explain the quotient rule. That's why product rule. That's why. Yeah. Okay. Now let us take another function. Say sin x upon x. Same thing. Now I want to differentiate. Now if f of x and d of x are differentiable at a point A such that g of a is not equals to 0, then so if f of g equals to x, then this quotient rule that you have to take the differentiation of this component. Now what is the case? Take the derivative of numerator into denominator minus derivative of denominator into numerator divided by denominator square, right? So this is the quotient rule. Someone raised hand. Yes, anyone? Any doubt in this part? In the previous part? Yes, Harshit?
No any doubt.
No, sir.
Just by
Okay.
mistake.
Okay.
In
Okay,
this
fine.
current setup, if I take sin x into x raised to minus 1, then I can apply the product rule.
Yeah, you can apply that rule also. Yeah. No
And
issue.
ideally, they should be equal.
Yeah, you will get the same answer.
Correct.
But I just want to apply the quotient rule. I just want to learn how to
Yeah,
apply
sure.
that.
Okay.
Yeah. So derivative of f of x here will be just keep the denominator as it is. Derivative of numerator, that is cos x, minus and numerator as it is, that is sin x, and derivative of denominator, that is x, that is 1, divided by square of this particular derivative, right? That is x square. This is a derivative of this particular thing. Now just try to apply here directly. We can do, but okay. Just try to find out the derivative of this particular function f dash of x.
Sir, may I ask something?
Yes.
Sir, can we access this document? Actually, I'm lagging behind, so I needed some shortcut to catch up.
This is
Actually,
taken from the slides only.
Okay.
Yeah.
Fine. Thank you, sir.
I just captured from the slide only. You can just refer to that. And questions are from activity only. Yeah.
Okay. Thank you, sir.
Yeah. Okay. Now just try to find out derivative of this two thing. What is derivative of this?
So the first one is 1 by x plus 1 whole square.
Minus 2 of x plus 1 whole square.
Yeah. Sorry. I totally, totally forgot about the concept. I'm sorry.
Now what about the second term? Sorry. X square 3x minus 1. Now I can apply the quotient rule here, right?
Yes, sir.
Yeah. 1. So if I apply this, take the denominator as it is. Derivative of the numerator is 2x minus, keep the numerator as it is x square. Derivative of this particular thing, that is 3 only, right? Divided by 3x plus 1 whole square.
Minus
and
1.
plus, yeah, and apply this to the minus because we have the minus sign, right? And here it will come minus 2 by x plus 1 whole square. So this is the derivative of this particular function. Okay, any doubt in this part?
In the denominator, it will be 3x minus 1, right?
Where?
Yes, sir. 3x minus 1 the whole
Whole
square.
square. First term,
In
denominator.
your lowest line in the denominator, you have taken 3x plus 1. It should be minus 1.
It's a minus 1. Okay, minus 1 is there. Okay, fine. 3x minus 1 whole square. Now this is the question. Yeah. Consider function. This is derivative of, find out the derivative of f of x. Log of 5 to the base x. Tell me how to do that. Hint is also given. Yes, anyone? This thing also you can apply or just
Yes, sir.
change
U
of
by
base ruler?
V.
Sorry?
U by V formula we can able to apply.
See, by using this particular hint, I can write it as 1 upon log of to the base 5 x, right? And take the derivative of this particular thing. Then use the quotient rule of derivative on specific function. We can do. Or other thing is that just change of base rule, that is log of 5 upon ln of x, right? I'm just converting this base x to e, right? So ln of 5 divided by ln of x. Now this ln of 5 is constant. Now just take this derivative of ln of x. That thing also you can do. Right? Now let us take, hello, are you getting it what I'm doing here?
Yes, yes. I
just
actually
applied
chose this base change thing.
Yeah. Now just take the ln of 5 is constant number. Okay. Now what is derivative of 1 upon ln x? Is anyone? How to find out derivative of 1 by ln of x?
Write it as ln x to the power minus
Sir,
1
minus 1 by x
and then
into
apply the
1 by
chain rule.
ln x whole square.
Okay, just 1 minute. So what you are saying, ln of x to the power minus 1. And then apply that particular case, right? Minus 1 ln x to the power minus 2.
Sir, it
Then,
should be, sir, we
Yes,
need
sir.
to differentiate the ln x as well. So it would be minus 1 by x.
Yes, sir.
also
Yes,
1
sir.
by x also, right?
Yeah.
Yes, sir.
Yeah. So if I see, this is basically a composite function. If I know the derivative of 1 by x, right? But I don't know the derivative of ln of x. So I can say my g of x is 1 by x and f of x is my ln of x, and my g of f of x is basically 1 upon ln of x, right?
Yes,
Is
sir.
the case? Yeah. Now just go to the composite. What is chain rule here? So if f of x and g of x are differentiable function, then so it is a function like that, and its derivative is like this. So I will again take the same thing. What is that? G of x is 1 by x, right? So I'm considering, okay, g of x is given. So I will here consider f of x as 1 by x, g of x as ln of x. Okay. Now f of g of x, sorry, f of g of x, yeah, f of g of x will be my 1 upon ln of x, right? Here you can see. Now if I want to find out the derivative of this particular function, what I can do, just differentiate the first thing in terms of by using the g of x. Basically derivative of this f dash of x is minus 1 by x square, but instead of x I can use ln of x, right?
Yes, sir.
Into g dash of x. What is g dash of x? Derivative of this particular function ln of x. That is my
ln
1
x,
by
so 1
x.
by x.
Yeah. So derivative will be 1 upon x into ln of x whole square. Now let's go back to this question. If I differentiate it, ln of 5 will be there, right? Into 1 by x, sorry, minus 1 by ln of x square, right? So it was minus. Okay, wait, I will put minus sign here. So this minus, right? Now we have simplified this term to try to bring out in this thing. How to do that?
So we can take the ln 5 and 1 ln x as 1 log. And the ln x, we can just bring it to the numerator and change the base. Base means like it's ln x, so it's base e. So it would be log e base x. So the x would be in the base. So the bases are same. So we can just
Same thing.
compose it there.
So I can write this as ln of 5 upon ln of x, right? Again ln of 5 upon ln of 5 into ln of x. Because I can say ln of x square is there, right? ln of
Yes,
5 is
sir.
also there. I just simply writing ln of x, ln of 5, ln of 5, and into 1 by x. So this is basically log of x to the 5, that is 1 upon. And here also if I take like this, here also into 1 upon log to the base 5x, right? So it will be square, and what will be remaining? 1 upon x ln of 5 log of x to the base 5 square and the minus sign. So our x square x, so B option is correct.
Yes.
Yeah. The simplification you should know. Yeah. So this is about the composite rule. Okay. So now what is L'Hospital rule? Yes, anyone, when we can apply that?
So when it's the indeterminate form, I mean when we
0 by 0, infinity.
0 by 0,
0 by 0, infinity by infinity,
Yeah.
and something to
So
the power
when
infinity.
you are getting like this form 0 by 0, infinity by infinity, you can directly apply L'Hospital rule. So what is in that rule? You can simply differentiate individually, right? Numerator and denominator. Differentiate ddd of x f of x upon ddd of g of x. It is not the quotient rule you are applying here. We are differentiating the numerator and denominator individually, right? In L'Hospital rule. So keep that point in mind. And also, these are the two like indeterminate form, then only we can apply this particular L'Hospital rule. But also if there are like this, say suppose infinity minus infinity, into raised to power 0, 1 raised to power infinity, z to the power infinity. If these such cases are there, then try to bring this in this form first. Okay. Try to bring this particular function in this form 0 by 0, infinity by infinity. Then only you can apply L'Hospital rule. Okay. Hello, are you getting
yes, sir.
it? Yeah.
Yes, sir.
So,
Got
yeah.
it.
So now just try to solve this question. Check whether the options can one of the apply L'Hospital rule to evaluate the limit or not. So first option, can we apply L'Hospital rule? X tends to 0.
Yes.
No, sir.
Sir, we can apply.
We can apply.
Yes, sir,
Yes,
we
sir,
can
we
apply.
can apply here.
0 by 0 form.
0 only, right?
So what if x is tends to infinity here?
Then in that case you cannot apply, because when what I have discussed in the last session, when x tends to infinity, try to bring it in the 1 by x form, right? So if I take the x common here, what I will get? 1 plus sin x by 1, right? By x, like this, right? Now if you apply the
Yes, sir.
limit, this is particular 0, so you will get 1 as the answer, right? So no need to apply the L'Hospital rule here.
Okay.
Yeah. Now this case, 0, 1 minus cos 0, that is 1. That is 0
This
by
is also
0.
0 by 0.
Yeah. Now what about this? 7 plus ln of 0, 0 plus 6. Is this 0 by 0 form?
No, sir. No,
No,
sir.
you
No,
cannot
sir.
apply.
No, sir.
What about this? Directly is infinity, right? So you cannot apply here also. So first and second options are correct. Simple L'Hospital rule. And okay, now let us discuss few examples. And okay, now which of the following statements are correct? Here we have two functions. This is one function. This is another function. Now try to differentiate the function first. So which rule we have to apply here? Yes, anyone?
Sir, we use
Composite
composition of
function rule.
functions, then apply it.
Chain rule.
Yeah, composition of
There is a composition of
functions.
functions, sir.
Then
Composition
we
of
have to apply the chain rule also. So how to proceed? Yes. I know the derivative of e to the power x, right? Directly.
Yes, sir. For first e to the power x, and then we need to apply the chain rule for x square and cos x.
Yeah. Then I have to do the derivative of this particular function also, right?
Yeah.
X square cos x. Basically 8x square into cos x. Now here which rule I have to apply?
So the chain rule, sir. I mean,
Here,
a dx of b, then
product rule.
that form.
Product
Yeah,
rule, sir.
product rule.
Cos x
Yeah.
Sorry, product rule, yeah.
X
Yeah.
square
So
minus
2x cos x minus of
x square
X
sin
square
x.
sin x.
right? That's it. So if you see which one is correct, 2x cos x minus x square sin x. Okay, this one is correct, right? So option C is correct here. Oh, wait, this is not correct.
So option D is
Yes,
correct, sir.
Option D is
Option.
correct. Yeah. Now try to find out for this particular thing. Differential ddx of e to the power x sine of x. Same thing.
So e to the power x sine
Sir,
x
sir, in the
into
meantime, I have a question. I mean,
Yes.
I don't know. I might have read the question wrong. I mean, not this one, the previous question that we just discussed. In the activity, I also got this wrong. I almost forgot about it. But the question that the L hospital thing, sir, in the portal, it is showing option B and C should be correct. I almost forgot to
No,
ask you about
in the
like what
option
should we
on
do.
the option A, I think there is one thing like it is limit x tends to infinity.
Yeah, it extends to infinity.
Yeah, and also check the option C. It is different, I guess.
Extends to 0 infinity. Oh yeah. Yes, I got it.
Yeah.
Right.
Yeah. Okay. So this question is clear, right? How to evaluate the different derivative of this particular expression by using the composite rule and the chain rule. Yeah.
Yes, sir.
Very simpler. Now, yes, try to apply L hospital rule here. Just first check whether we can apply L hospital rule or not here.
We can apply
So
it.
We
sin
can say 0 by
0
0.
by
Yes, we
0.
can
So
apply.
0. So what is the derivative of sin x?
Cos x.
Cos x.
Cos x.
Cos x. Individually, we have to take the derivative of this numerator denominator, right? So derivative of root x.
1 by 2 root x.
2 root x.
1 by 2 root x.
2 root x. Now just put limit x tends to 0. What is cos 0?
1.
1.
Cos 0 and 1 upon 2 root 0. So basically it is 0 only, right?
Yes,
Yes,
sir.
Yes, sir.
So answer is 0. Yeah, simple. Then fourth question, yes. Find out the value of root 8 into this term. So my limit is x tends to 1. F of x is basically 9 minus x square minus f of 1. Basically, if I put 1 here, what I will get? Root 8.
Yes, sir.
And x minus 1. Now try to evaluate.
So it is
Put
also
x equals to 1.
So we need to put the
Zero.
we need to
0 by
use the
0.
hospital. It is 0 by
We
0.
can use L hospital.
Without root.
Yeah, now just take the derivative of numerator. What is the derivative of this particular function?
So
1 by
1 by 2,
1 by 2
9 minus x squared into minus 2x. I mean in the numerator.
x, sir.
Yeah. Minus
2x.
2x, right?
Numerator minus 2x.
Yeah.
Yeah. And the derivative of minus constant function is 0 only. Right? And
Yes, sir.
derivative of denominator here?
It's a 1, sir.
1, sir.
1 only, right? Now just put the x equals to 1 limit here. What you will get? So these two will get cancelled. So minus x upon
Minus
under
1
root
by
of
root 8.
9 minus x square. So if I put 1 minus 1
By
under
root
root
Minus
of 8.
root.
Yeah.
So here
And
we have
here
another
also
We have a
root.
root 8 in
1.
multiplication, so it's minus
Yeah.
1.
Yeah.
So it will be
So
cancelled.
we
So
have
negative.
we have minus 1 is the answer. Okay. Now just try to find out the question number 5, like limit x tends to infinity, x into e to the power minus x. If you put here, it is 0, right? So 0 into infinity form. Now try to evaluate this. Try to see how to evaluate or try to bring in the 0 by 0 or infinity by infinity form.
So if we
Can we
bring the
bring?
to the power
Yeah.
x below, so it's infinity by infinity. Sorry, it's 0 by infinity, I guess. No, it's infinity by infinity form.
Infinity by
Infinity by infinity form. Yeah, I didn't
If
see
I
the
write
limit. Sorry.
like this, yeah,
Yeah.
it is
So it's
infinity
infinity
by
by
infinity, right?
Yeah.
So now text, just apply the L hospital rule here. Tell me.
So it's 1 by e raised to x. I mean the final form.
Yeah, differentiable. Now,
0.
yeah, 1 upon e to the power infinity.
1 by infinity, so it's 0.
0 only,
Sir,
right?
if we didn't apply the L'Hospital rule, we have the sequence like this x by e power x. So for that one, we need to consider which tends to infinity very quick, like x or e to the power x. So
X,
e to the
yeah.
power x is quick, so we consider e to the power x. So we are focusing on that one.
Sorry, I didn't get it. Like, so
Um,
why we are bringing it down? You are saying, right? Either you can do like this also, na? Like e to the power minus x upon 1 upon x also, right? Same thing. Here also you will get 0 by 0 form.
Okay, sir. Okay, yeah, got it.
Yeah. We just want to make like in the proper infinity by infinity or 0 by 0 form. If we have other indeterminate form, then only we can apply an hospital rule. Otherwise not, right?
Okay, sir.
Yeah. So I guess we have done this question. Again, this is a question from activity. Okay. Now let's go for question number 8. We have given f of x plus y, f of x into f of y, and f of 9 equals to 6, f dash of 0 equals to 4. Find the value of f dash of 9. Yes, anyone? How to approach this question?
So it's confusing, sir.
Can we think of this function as log? So, because it's showing the property of log to me.
No.
Well, like if we take x
No,
as
no.
9 and
Sorry.
y as 0 and apply f of
X
9
is
equals to
0 and y is
If two
9,
numbers,
right?
yes.
if we,
So f of, yes, Manas, go ahead.
it is showing some exponential property. If two numbers are multiplied, then their power is added. So it's something like that. There is two numbers multiplied and the x and y are added. So maybe it is an exponential function or something like that. Product function.
We are given this particular function like this only, right? Now we need to find out the function. Yeah. So I can say x equals to 0, y equals to 9, or my y equals to 0, x equals to 9, right? I can because I have given this value for f of 9 and 0, right? That's why I'm considering 0 and 9.
Okay.
Yeah. So just put, so x equals to 0 and y equals to 9, that is here. So I will get f of 0 into f of 9, right? Here also f of 9 is there, right? So into f of 0 into f of 9, but what is the f of 9 is given to us? 6, right? So basically f of 0 will be 1 only, right?
Yes.
So here from I am getting f of 0 equals to 1. Okay, but what we have to find out?
It's f dash of 9.
Yeah. So even if I use this thing like f of,
We can
say,
use the
9,
direct definition of that. Like
yeah. So basically it is 6 into, sorry, it is 6, it is f of 0. If we differentiate that, f dash of 9 equals 6 into f dash of 0. So 6 into f dash of 0.
The 24, sir.
24, like this we can get.
20.
Okay, just you can try it out. You can do another way also.
Okay, sir.
Yeah. So this is about the limit,
Sir,
continuity, and derivative. Yes.
I can get it that question, sir. Could you rewrite that one, sir, so you quickly
Just put x
what is
equals to 0, y equals to 9, because we have given this two number, right? F of 9 equals to f dash of 0 equals to 4, right?
But sir, that
So
is
from,
x is equal to 9, right? F of 9 means x equal to 9.
you can consider that, okay, you can say 9 also, here 0 also, no issue.
Oh, okay, okay, okay.
Yeah, it will be
Sorry,
same
f
thing.
prime of 0 is
Sorry?
oh, there. Okay, sir. Okay, sir. Got it, sir. Yeah.
Yeah, we have to find now f dash of 9 only, right?
Sir, I have a small question. F of 9 is 6, so f prime of 9 they are asking. So we are just derivative and give it 0.
Why?
So why we didn't do that, sir?
Sorry.
Sir, they
differentiating.
are giving f of 9 is f of 9 is 6. They are asking f prime of 9. So we just derivative that one.
This one.
Function f of x
No,
is
no. This
constant,
is
then
Derivative
yeah.
of 6 is
This
0,
is
right? Constant.
f of 9. Then the value of this particular function when x equal to 9 is 6. It is not equals to f of 6 equals to 9. Like this. Okay.
Okay,
so if
sir.
f
Okay.
of x equals to 6, then it is a constant function. Then we can say derivative is 0. Right?
Okay, sir. Yeah, fine.
Yeah. Okay. Okay, so this is about the limit and derivative. Now, last topic is tangents and derivative and linear approximation. So, say suppose we have function f differentiable at a point A, then the tangent of to particular this particular curve at A exists and is given by this is the equation of a tangent to this particular function, right? And say suppose if I want to find out the slope, then in that case, what you have to do? This is given. This is a
Sir, the
tangent,
f dash
right?
sir, the f dash of A would be the slope.
Yeah, it is
Yes,
the
sir.
slope only. Or if you are getting any expression, say 3x square plus 9, you can simply differentiate it, right? So it
Yes,
will
sir.
give me the slope at any particular point. So at
Yes, sir.
x equals to a, you will get just differentiate y dash of, just put the value of a, you will get the slope. So this is the equation of a tangent. If you differentiate it, or you can directly say it is if it is in this form only, then you can say f dash of a. Otherwise, it is simplified form, then you have to take the derivative. Okay. So this is the tangents, and what is linear approximation here? If f of x differentiable at a, then the best linear approximation is like this. Okay, same expression is there, but here we are considering this linear approximation f of a plus f dash of a x minus of a. Okay, and conversely, if there is a best linear approximation for f at a, then the f is differentiable at a. And the converse is also true, right? So now just keep this in mind. Tangents. This is a expression like f dash of a x minus of a plus f of a, right? And this is for linear approximation. Now let's try to find out the. Okay, can anyone solve this first question? It is simpler. It is from the week. Okay, we have discussed the differentiable especially, so we can directly differentiate the function and find out the value of this particular slope at this point, right?
Yes, sir.
So what is m1, m2, m3? Please tell me.
Sir, m2 is 3, m3 is
m2 is
6.
3, m3 is 6, and what is m1?
M1 is also 6, sir.
Yeah, it is also
M1 is
6.
also 6. So basically, we have to differentiate this function. We'll get 3x square plus 3 and just put the value of this thing. When x equals to -1, my m1 will be 6. When x equals to 0, my m2 will be 3. And when x equals to 1, my m3 will be 6, right? So we have asked for m1 plus m2 plus m3.
15.
So that is 15.
Yeah,
So
M1 will be
15.
-6.
How? If you just put here -1, it will be 3 plus 3 only, right? We have to differentiate this particular function in order to find out the slope.
Yeah, yeah.
These are the slopes of the tangents. Yeah. Okay. Any doubt in this part?
No, sir.
Okay.
No, sir.
Just try for second one.
The second option would be correct. Rest I gotta see.
So at a vertex we are talking about, right?
Yes, sir.
Same thing we have to do. We have to find out the tangent to the parabola, find out the equation, and then just find out the slope. So what is the vertex here for both the cases? What is the vertex? X or K? H comma K, right?
H comma K.
X coordinate is H, right?
H, yeah.
Yeah. So how to find out the equation? Sorry, for the slope. So tangent to the parabola. By using this particular thing. Can simplify it, right? So keep y equals to a x minus h whole square plus k, right? Now you can consider it as f of x, and just what is the tangent? F dash of a x minus a plus f of a. So what is my f dash of x here? A twice of A into x minus h, right?
Yes, sir.
If you put x equals to A, but I have to check here A is at that particular point. So my point is vertex, right? That
Yes,
is
sir.
x equals to
H.
h. So put x equals to h here. So f dash of h will be 0, right?
Yes, sir.
So my equation like this, f dash of h, x minus h plus f of h. Right. So here it is 0, right? This is 0, means this whole term is 0.
Yes, sir.
Yeah, so f of h will be my tangent. So just put f of h in here. So h will get 0, right? Cancel.
Yes.
This is
Yes, sir.
0. So y minus k equals to 0. Basically, that is y equals to
Y
k.
equals to K.
Okay, this is my tangent, right? Yeah.
Yes,
So
sir.
option B is correct. Now check for option C or D. Same function is there, ax square. Just differentiate it. Just try to bring this in this form. So just keep in mind, this is our generalized function f dash of a, x minus a plus f of a.
Sir, option C is
Yeah, so just differentiate it. Derivative of y is 2ax, right?
Yes, sir.
What is f dash of a? Just put x equals to a. So I will get
2A square.
2a square. X minus a as it is. What is f of a? Just put x equals to a.
A cube.
A cube. That is my a cube, right? So just simplify it. So basically you will get 2a square x minus 2a cube plus a cube.
Plus A cube.
Yeah, so minus 2a cube plus a cube will be 2a cube only, right? Minus
So minus A cube.
minus a cube, right? Here it is square. So I can take
A square common, sir.
common. Yeah, a square common, so it will be 2x minus a. So my option B will be correct one, right?
C. Yes.
C, sorry, C will be correct. This is the one. Okay, anyone, any doubt? Just apply the same thing here. Just put the generalized equation, derivative it, put the particular point, then x minus a, then plus f of a. Okay. Now apply the same thing, concept what we have discussed just now, and try to find out the value of f dash of 1. We have 3 questions remaining. Let's try to do that.
Sir, I've already calculated this, so I don't know. Should I say? How did I do it?
You can wait for 1 minute.
Okay, okay, sir. Okay.
Yeah. Applying this concept, not directly, you can also apply, you can find out, but
Yes, I mean, we like according
Ah.
to the question, we can see like
Yeah.
the thing.
So f of a, just put a equals to 1, right? So f dash of 1 equals to, sorry, x minus 1 plus f of 1.
Yes, sir.
So what is f dash of 1? We have to find out. X
Yeah.
minus 1 we can do. Yeah.
Yeah. We can.
So what is f of 1 here? Yes. What is the value?
Give me a second. F of 1. Sir, I didn't go that way. I just put that one. I just derived that. Then I went for the slope actually. So I did the intercept slope form and just made it. I mean,
Yeah.
like
So yeah, so that is the way you can do. But here in this week we are learning this thing. So by
Oh
using
yeah,
this
okay,
way, I
okay,
want
okay,
to-
sir. Okay, got it, sir.
Yeah.
One is
In
0.
exam you can do anything. But
Okay,
here
sir,
we are just doing, yeah. So f of 1 will be 0 because here 1 comma 0 means at x equals to 1, f of 1 is 0, right?
F of 1 is 0, yeah.
Like 0. So this is basically my y. So the curve will present what we have to find out. Okay, so we have f dash of 1, x minus 1. Now find out the value of f dash of 1. So just we have given the point. So it passes through the point 5 comma 8. So when y equals to 5, x equals to, sorry, when x equals to 5, my y
X equals to 5,
8.
y equals to 8.
Yeah, just put 5 minus 1. So f dash of 1 into 4, this is 8. So my f dash of 1 will be 2, right?
Yes, sir.
Yeah. So 2 is the correct answer. Yes, anyone, any doubt in this part? Hello?
Yes, sir, you're audible, sir.
Yeah, okay. Or either way, you can apply that slope point for on y2 minus y1, x2 minus x1.
So I found it
8
pretty
minus
easy, that's
0,
why.
5 minus 1, 8 by 4, 2, right?
8 by 4, 2, yeah.
Yeah. But in this week, we are learning about this concept, so that's why we're going through that.
Okay, sir, okay.
Yeah.
Got it.
So question number 6, yes. Question number 6 is that you can do that similar question. Question number 7 and 8.
Sir, I have issue with this question.
Okay, we'll
I
discuss.
couldn't do it.
Okay, first tell me question number 7. So same thing, use the linear approximation. Okay, so L of x. What is the linear approximation equation here? F dash of a, x minus a plus
f of a.
f of a.
Yes, sir.
At x equals to 4. Now just put f dash of a. What is the derivative of f dash of x?
So 1 by 2 root x.
1 by 2 root x. If I put a, that is 4 here, what I will get?
2 into 2, 4.
1 by 4.
Sorry, 1 by 1 by 4. Sorry.
So 1 by 4. Yeah. So that is x minus a.
Yes, sir, so far I have done. I don't know what did I
X
do.
minus a means here 4, right? And plus f of 4. What is f of 4 here? Yes, anyone?
So f of 4 is 2.
F of 4 is 2, right? So that is 2. Now
And
I
x
have
is
1 by 4, x minus 4, f. This is my linear approximate equation, right?
Yes,
If
sir.
I can put any value here, I can get. Okay. Now what should I put? I should put x equals to 4.4 or x
4.4,
equals
yeah.
to 0.4. What?
4.4.
Yes, anyone? 4.4, right? Because our
4.4.
expression is under root of x. So we need to find out 4.4.
Yes, sir.
Just replace x by 4.4. So 4.4. What will get? 1 by 4. 4.4 minus 4 plus 2. It will be 1 by 4. 0.4 plus 2. It will be 2 plus 0.1. So it will be 2.1.
Oh,
Answer
okay,
will be
sir.
2.1. Right?
Okay. I got it. Like exactly where I did wrong. Okay. I didn't put the 2 point. I mean, I didn't put the 4.4. I did.
4.
I took the square root and then I didn't see that both are having square root. So okay, sir. Got it, sir.
Yeah. Okay. And same thing here. But here you see our expression is 1 plus x to the power 4. And here I have to find out 1.01. Right? So 1 is already here. So after
Yes.
finding out the expression, I have to put x equals to 0.01.
0.01.
Yeah. Then you will get the value of this. So please look at the function. What is your function? And accordingly, you have to put the value. Okay. Anyone, any doubt in this part? Anyone in week 8?
No, sir.
A simpler one, just revise it once and just solve the questions. Yeah, that will be enough. Okay. Okay. Thank you then. Yeah.
Sir, are you gonna take questions from the mock as well? I mean, I have one doubt around mock. I mean, not like
Which
for
mock?
now. Sir, the mock that came, like mock 4, week
Okay.
5, 6. So that one, sir.
Which question number?
Let me see, sir. It was, sir, question number 2. Sir, option number 1. Question number 2, option number 1. It is saying correct, but I don't know how to. I'm like, how is it correct? If you can just help me.
Question number 2, option number
1.
We have released the solution. Have you gone through that?
I just saw that solution. Sorry, sir. Okay, sir. I'll just go through it.
Yeah. Go through it, or tomorrow we have session. You can ask tomorrow.
Yeah, okay, sir. Got it. Thank you.
Yeah. Okay. Thank you, everyone. Bye-bye. Good night.
Thank you, sir. Good night.
Thank you, sir. Good night.
Thank you, sir.
Thank you,
Good
sir.
night, sir. It was very nice session.
Thank you, sir.